Hello friends, warm welcome to all of you to my channel. Good day friends, welcome to the session of Mainframe Tricky Interview Questions for CICS. Moving to question 1, what is CICS? The answer is CICS stands for Customer Information Control System. It is a transaction processing system designed to provide online transaction processing capabilities on IBM mainframe systems. Moving to question number 2. What are the different components of CICS? The answer is the main components of CICS are Terminal Control Program, that is TCP, Program Control Program, that is PCP, File Control Program, that is FCP, and Data Control Program, that is DCP. Moving to question number 3. How does CICS handle concurrent transactions? The answer is CICS uses a task control block, that is TCB, for each transaction, which allows it to manage concurrent transactions efficiently. The TCB keeps track of the state of the transaction and ensures proper synchronization. Moving to question number 4. What are the advantages of using CICS? The answer is CICS offers several advantages, including online transaction processing capabilities, efficient handling of concurrent users and transactions, support for various programming languages like COBOL, PLI, assembler, etc., integrated file and data management facilities, built-in security features, scalability and reliability for critical business applications. Moving to question number 5. Explain the concept of CICS task and transaction. The answer is, in CICS, a task represents the execution of a specific transaction or unit of work. A transaction, on the other hand, is a logical unit of work initiated by a user or an application program. A task is created when a transaction is started and remains active until the transaction completes its processing. Okay, so moving to question number 6. What is a CICS program and how is it different from a batch program? The answer is, a CICS program is a transactional program specifically designed to run under CICS control. Unlike batch programs, CICS programs run interactively in response to user-initiated transactions. They have access to CICS services and can perform online processing. Moving to question number 7. How does CICS handle file processing? The answer is, CICS provides the file control program, that is FCP, to handle file processing. It supports various file access methods like VSAM, QSAM, and BDAM. CICS maintains data integrity and ensures proper concurrent access to files. Moving to question number 8. What are the different types of CICS files? The answer is, CICS supports several file types, including temporary storage, that is TSQ, sequential data stored in a queue-like structure. Next is transient data queue, that is TDQ. It holds data in the form of records. Third one is physical sequential, that is PS file. accessed sequentially in a forward-only manner. Next is virtual storage access method, that is VSAM files, allows direct access to data via keys. Okay, moving to question number 9. What is a CICS map and what is its purpose? The answer is a CICS map is a screen layout or user interface used to display data to the user and receive input from them. It defines the presentation of data on the terminal screen, including fields, labels, and attributes. Moving to question number 10. Explain the concept of CICS program restartability. The answer is CICS programs are designed to be restartable, meaning they can be resumed from a point of interruption without reprocessing the entire transaction. This capability ensures data integrity and efficient recovery from failures. Moving to question number 11. How does CICS handle error and exception? The answer is CICS provides the exception handling routine, that is EIB-RESP and EIB-RESP2, to capture errors and exceptions during program execution. It allows programs to take appropriate actions based on the error codes returned by CICS. Moving to question number 12. What is a TDQ, that is Transient Data Queue, in CICS, and how is it used? The answer is a TDQ is a queue-like structure in CICS used to hold data in the form of records temporarily. It allows different programs to share data asynchronously. Programs can write data into a TDQ and other programs can read from it later. Moving to question number 13. How does CICS provide support for intercommunication between different programs? The answer is CICS provides various mechanisms for intercommunication, such as number 1, program to program, that is P2P communication using COM area or channel based communication. Next is sending and receiving messages using CICS built-in message queues. Number 3, sharing data through shared data tables like temporary storage queues, that is TSQ, or transient data queues, that is TDQ. Okay, so moving on to question number 14. What is the difference between CICS and IMS, that is Information Management System? The answer is CICS is primarily a transaction processing system that focuses on online transaction processing, while IMS is a hierarchical database management system. IMS provides data management capabilities for batch and online applications. Moving to question number 15. How can you debug a CICS program? The answer is CICS programs can be debugged using various tools such as CICS transaction dumps, trace facilities, and interactive debugging tools like the CICS application debugger, that is CAD. These tools help identify and resolve issues in CICS programs. Okay, so moving on to question number 16. Explain the concepts of MVS, JCL, and VSAM in the context of CICS. The answer is, in the context of CICS, MVS, that is multiple virtual storage, JCL, that is job control language, and VSAM, that is virtual storage access method, are important concepts. Here is an explanation of each concept in brief. First one is MVS, that is multiple virtual storage. MVS is an operating system developed by IBM for mainframe computers. It provides the foundation for running various software applications, including CICS. MVS manages system resources such as memory, CPU, and devices, and provides services for task scheduling, job management, and data access. The next is JCL, that is Job Control Language. JCL is a scripting language used to control the execution of programs and jobs in the MVS operating system. It defines the sequence of steps, resources, and parameters required to execute a job. JCL is used to submit CICS related tasks or batch jobs that interact with CICS. It specifies the programs to be executed, input-output files, and other job control statements. Next comes VSAM, that is Virtual Storage Access Method. VSAM is a file access method provided by IBM for organizing and accessing data in mainframe environments. VSAM offers efficient access to large volumes of data and supports random, sequential, and direct access methods. In the context of CICS, VSAM is commonly used for starting and accessing CICS files such as CICS system files, temporary storage queues, that is TSQs, and transient data queues, that is TDQs. Overall, MVS provides the underlying operating system infrastructure. JCL defines the job control statements to execute CICS related tasks, and VSAM is used as the file access method for CICS data storage and retrieval. Understanding these concepts is important for working with CICS in the mainframe environment. Moving to question number 17. What are the different ways of invoking a CICS program? The answer is there are several ways to invoke a CICS program. I am mentioning some common methods here. First one is terminal initiated. Users can initiate a CICS program by interacting with a terminal or a terminal emulator. They enter a transaction code or select a menu option which triggers the execution of the corresponding CICS program. Next is program to program, that is P2P communication. CICS programs can be invoked by other CICS programs using program to program communication mechanisms. This can be achieved through COM area or communication area, or by passing data through channels or containers. Next is Transaction Server API. CICS provides Transaction Server API, which allows applications to invoke CICS programs using programming languages like COBOL, PLI, Assembler, or Java. Applications make API calls to start and communicate with CICS transactions and programs. Next comes CICS Command Level Interface, that is CLI. CICS CLI is a set of commands that can be used to interact with CICS programs. These commands can be executed from a terminal, batch jobs, or system commands. They enable the execution and control of CICS programs. Next is CICS Web Services. CICS supports the exposure of its programs as web services. Programs can be invoked through HTTP or SOAP requests using web service protocols. This allows integration with web-based applications and services. Next is batch job execution. CICS programs can also be invoked from batch jobs using JCL, that is Job Control Language. Batch jobs can submit CICS tasks or use CICS API calls to interact with CICS programs. These are some of the common methods for invoking CICS programs. The choice of invocation method depends on the specific requirements and the integration approach used in the system. Moving to question number 18. How can you control the flow of execution within a CICS program? The answer is, within a CICS program, you can control the flow of execution using various programming constructs and CICS specific features. Here are some ways to control the flow of execution in a CICS program. Number 1. Conditional statements. You can use conditional statements like if, then, else, evaluate, or case statements to make decisions based on certain conditions. These statements allow you to branch the execution flow based on the evaluation of expressions or conditions. Number 2. Looping constructs. Looping constructs like do while, perform until, or perform varying can be used to repeat a block of code until a specific condition is met. These constructs enable you to iterate through a set of instructions repeatedly. Number 3. CICS command level programming. CICS provides commands like send, receive, link, Xctl, and return, which allow you to transfer control between programs and tasks. By issuing these commands at appropriate points in your program, you can control the flow of execution between different program modules or transactions. Number 4. Subroutine calls. You can modularize your CICS programs by dividing them into subroutines or procedures. By calling these subroutines using perform or call statements, you can control the flow of execution within the program and execute specific logic based on the subroutine being invoked. Number 5. CICS task control. CICS programs run as part of a CICS task. CICS provides APIs and facilities to manage tasks such as starting tasks, suspending tasks, and resuming tasks. By utilizing these task control features, you can control the execution flow within a program based on task-related conditions or requirements. Next is exception handling. CICS programs can handle exceptions and errors using CICS exception handling routines or by capturing and processing specific response codes. By incorporating exception handling logic, you can control the program flow based on the occurrence of errors or exceptional situations. These techniques and constructs provide flexibility and control over the execution flow within a CICS program. The specific approach you choose depends on the requirements of your program and the desired behavior. Okay, moving to question number 19. How can you pass data between CICS programs? The answer is, in CICS, there are multiple ways to pass data between programs. Here I am mentioning some common methods. First one is COM area, that is communication area. COM area is a shared data area used to pass data between CICS programs. The sending program writes data into the COM area and the receiving program reads the data from it. The COM area can be defined as a data structure in COBOL or PLI, or as a working storage area in assembler. Next is channels and containers. Channels and containers provide a flexible mechanism for passing data between CICS programs. A channel is a named data area that holds data, and containers are individual data items within a channel. Programs can write data to channels and retrieve the data from channels using container operations. Next comes Program Communication Area, that is PCA. The Program Communication Area is a data area associated with each CICS program. It allows programs to pass data to other programs by writing values into specific fields in the PCA. The receiving program can access the data by reading the corresponding fields in its PCA. Next comes data queues. CICS provides temporary storage queues, that is TS queues, and transient data queues, that is TD queues, for passing data between programs asynchronously. A sending program writes data to a queue and the receiving program reads the data from the same queue at a later time. Next comes passing parameters. CICS programs can pass parameters to each other using the program linkage or using language specific mechanisms like COBOL call statements or PLI entry statements. Parameters can be passed by reference or by value. Next comes shared data tables. CICS supports shared data tables like temporary storage queues, that is TS queues, and transient data queues, that is TD queues, that can be accessed by multiple programs. Programs can read from and write to these shared data tables to exchange information. The choice of data passing method depends on factors such as the nature and size of the data, the relationship between the programs, and the desired level of synchronization. It's important to ensure proper synchronization and data integrity when passing data between CICS programs. Moving to question number 20. What is a CICS transaction dump and how can it be analyzed? The answer is a CICS transaction dump, also known as an abend dump or a system dump, is a snapshot of the system state taken when an abnormal termination or abend occurs in a CICS transaction. It captures the program status, register contents, storage areas, and other relevant information at the time of the abend. Analyzing a CICS transaction dump can provide valuable insights into the cause of the abend and help in troubleshooting and resolving the issue. Here is a high-level overview of how a CICS transaction dump can be analyzed. The first is obtaining the dump. When an abend occurs, CICS generates a transaction dump. The dump can be obtained from various sources such as system logs, diagnostic tools, or dump datasets, depending on the system configuration. Next is identifying the dump type. CICS transaction dumps can be generated in different formats such as sysudump or sysmdump. The dump type affects the analysis process and the tools that can be used. Next is reviewing the dump contents. The transaction dump contains vital information, including the program counter, storage contents, registers, program trace, and abent code. Reviewing these contents can provide insights into the state of the program at the time of the abent. Then comes identifying the abent code. The abent code in the transaction dump helps identify the type of abent that occurred. It provides a clue about the cause of the termination. Next is analyzing the program trace. The program trace within the transaction dump shows the sequence of program instructions executed before the abent. It can help pinpoint the exact location where the abent occurred. Next is examining storage contents. Analyzing the storage contents within the dump can reveal valuable information such as variable values, data corruption, or memory allocation issues. Next is using debugging tools. Debugging tools specific to CICS, such as the CICS application debugger, can be utilized to analyze the transaction dump. It is also referred as CAD. These tools provide interactive capabilities to navigate through the dump, examine data, and understand the program flow. Next is utilizing documentation and resources. Referring to CICS manuals, technical documentation, and online resources can help in understanding the abent code, interpreting the dump contents, and finding potential solutions or workarounds for the issue. Analyzing a CICS transaction dump requires expertise and familiarity with CICS internals, debugging techniques, and system-specific configurations. It is often performed by experienced system programmers or support personnel who are skilled in diagnosing and resolving abents. Okay, so moving on to question number 21. Says mention the commonly used tables in CICS. The answer is in CICS there are several tables used for various purposes. Here I am mentioning some commonly used CICS tables. First one is PCT, that is Program Control Table. The PCT is a CICS system table that contains information about all the active programs in the CICS region. It maintains the program name, load module information, program attributes, and other related data. Next comes FCT, that is File Control Table. The FCT is a CICS system table that stores information about the files accessed by CICS programs. It maintains details like file name, file organization, access methods, record formats, and file attributes. Next is TD, that is Terminal Definition Table. The TD table holds information about the terminals or devices connected to the CICS system. It includes details such as terminal type, device characteristics, communication protocols, and screen layouts. Next comes DT, that is Destination Table. The DT table is used for defining destinations within CICS. Destinations represent external resources or systems with which CICS interacts, such as databases, message queues, or other CICS regions. Next is TS, that is Temporary Storage Queue Table. The TS queue table contains information about the temporary storage queues, that is TS queues, defined in CICS. It maintains the names, attributes, and other parameters of the TS queues. Next is TDQ, that is Transient Data Queue Table. The TDQ table holds information about the transient data queues, that is TDQs, defined in CICS. It maintains the names, attributes, and other parameters of the TDQs used for passing data between programs. Next comes TCT, that is Task Control Table. The TCT table is a system table that maintains information about the tasks or transactions running in CICS. It holds data related to tasks, program counters, task attributes, resource uses, and other control information. Then comes RCT, that is Resource Control Table. The RCT table is used for managing system resources in CICS. It includes information about files, databases, program libraries, security definitions, and other system resources. Next comes TDQ, that is Temporary Data Queue Table. The TDQ table stores information about the temporary data queues defined in CICS. It maintains the names, attributes, and other parameters of the TDQs used for temporary storage. So these are some of the commonly used tables in CICS. Each table serves a specific purpose and plays a crucial role in managing and controlling various aspects of CICS operations and resource uses. Okay, moving on to question number 22. What is the difference between a transient and a permanent dataset in CICS? The answer is, in the context of CICS, that is Customer Information Control System, a transient dataset and a permanent dataset refer to different types of datasets used by CICS. First one is transient dataset. A transient dataset in CICS is a temporary dataset that exists only for the duration of a single transaction. It is created dynamically during the transaction and is typically used for temporary storage or as a scratchpad for intermediate processing. Transient datasets are not preserved across multiple transactions or system restarts. They are automatically deleted when the transaction completes or abnormally terminates. Next is permanent dataset. A permanent dataset in CICS is a persistent dataset that is intended to be preserved for an extended period of time. It is typically used to store permanent data that needs to be retained across multiple transactions and system restarts. Permanent datasets are typically defined and managed outside of CICS, such as in an external file system like ZOS datasets, example VSAM, QSAM, or DB2, or in a database management system, that is DBMS, like DB2 or IMS. CICS provides facilities to access and manipulate permanent datasets through file control commands and associated programming interfaces. In summary, the key differences between transient and permanent datasets in CICS are: transient datasets are temporary and exist only for the duration of a single transaction, while permanent datasets are persistent and preserved across transactions. Transient datasets are typically used for temporary storage within a transaction, while permanent datasets store permanent data that needs to be retained over a longer period. Transient datasets are created dynamically during the transaction, while permanent datasets are typically defined and managed outside of CICS. Okay, moving on to question number 23. How can we read a CSAM file in CICS? The answer is, to read a CSAM, that is CICS Sequential Access Method file in CICS, you can use the CICS file control commands and associated programming interfaces. Here is a general overview of the steps involved. First one is define the CSAM file. The CSAM file needs to be defined to CICS using the appropriate file control definition language. Example, the CDA transaction. This includes specifying the file attributes such as file name, organization, that is sequential, record length, etc. Next step is to open the file. Before reading the CSAM file, you need to open it using the CICS file control command. The command to open a file is exec CICS open. Next step is to position the file. If you need to read the CSAM file from a specific point, you can use the CICS file control command exec CICS read update to position the file at the desired record. If you want to start reading from the beginning of the file, you may skip this step. Next step is reading the file. To read records from the CSAM file, you can use the CICS file control command exec CICS read. This command retrieves the next sequential record from the file. You will typically need to provide a working storage area to receive the record data. Next is to process the record. Once you have read a record from the CSAM file, you can process the data as required within your CICS program. Next is to repeat steps 4 and 5. To read subsequent records from the CSAM file, you can repeat steps 4 and 5 until you have processed all the desired records. Next is to close the file. After you have finished reading the CSAM file, you must close it using the CICS file control command exec CICS close. Here I am furnishing an example to open, read and close a file. Look at this carefully. Moving to question number 24. What does exec CICS link command do? The answer is, the exec CICS link command in CICS is used to transfer control from one program to another program within the same CICS region. It allows programs to call and communicate with each other. When you issue the exec CICS link command, CICS performs the following actions. First is, it saves the current program's context. CICS saves the state of the current program, including the program counter, register values, and other relevant control information. Next, it transfers control to the target program. CICS transfers control to the specified target program. The target program can be another CICS application program or a CICS supplied system program. Next, it executes the target program. The target program is executed and performs its processing. Next is, it returns control to the calling program. After the target program completes its processing, control returns to the calling program. Next, it restores the saved context. CICS restores the saved context of the calling program, allowing it to resume execution from where it left off. Here I have given an example. Please look at it. Okay, moving to the next question. Question number 25. What does Xctl Xctl do? The answer is the Xctl Xctl command in Kicks is used to transfer control from one program to another program within the same Kicks region. However, the key difference between Xctl link and Xctl Xctl is how control is transferred and the impact on the calling program. When you issue the Xctl Xctl command, Kicks performs the following actions. At first, it ends the current program. Unlike the Xctl link command, which saves the context of the calling program, the Xctl command terminates the execution of the calling program. It does not save any program context. Then it transfers control to the target program. Kicks transfers control directly to the specified target program, bypassing the initial program that used the Xctl command. Then it executes the target program. The target program is executed and performs its processing. Next is program continuation. Since the calling program is terminated, there is no automatic return to the calling program. If program continuation is required after executing the target program, it must be explicitly coded within the target program itself. Here I have given an example. Please go through it carefully. Okay, so moving on to question number 26. What are the key differences between Xctl link and Xctl Xctl? The answer is, in summary, the key differences between Xctl link and Xctl Xctl are: Xctl link saves the context of the calling program and allows it to resume execution after the target program completes. Xctl Xctl terminates the execution of the calling program and transfers control directly to the target program with no automatic return to the calling program. So the choice between using Xctl link and Xctl Xctl depends on the desired program flow and the need for program continuation after invoking the target program. Moving to question number 27. What does Xctl return do? The answer is, the Xctl return command in Kicks is used to terminate the execution of a Kicks program and return control to the calling program. It allows a program to gracefully exit and provide a result or status information back to the calling program. When you issue the Xctl return command, Kicks performs the following actions. At first, it sets the return code. You can specify a return code in the return command, indicating the status or result of the program execution. The return code can be a numeric value that carries specific meaning to the calling program. It restores the context of the calling program. Kicks restores the saved context of the calling program, allowing it to resume execution from where it left off. It returns control to the calling program. Control is transferred back to the calling program at the point immediately following the original Xctl link or Xctl command that invoked the returning program. It provides the return code to the calling program. The return code specified in the return command is made available to the calling program. The calling program can examine this return code to determine the outcome or status of the executed program. The Xctl return command is typically used when a program has completed its processing or encounters a condition where it needs to exit gracefully. By providing a return code, the program can convey information to the calling program about the execution result, errors, or other relevant information. Here I have furnished an example. Please go through it. Okay, moving on to question number 28. What does Xctl receive do? The answer is the Xctl receive command in Kicks is used to receive data from a terminal or communication device within a Kicks program. It allows the program to interact with the user or external system by capturing input data. When you issue the Xctl receive command, Kicks performs the following actions. Waits for input. The receive command causes the program execution to pause and wait for input from the terminal or communication device. It allows the program to receive user input or data sent from external systems. Next is it receives the input data. When input is available, Kicks captures the input data and stores it in a designated storage area defined by the program. This can be a working storage area or a COM area that is shared between the program and the terminal. Then it continues program execution. After receiving the input data, the program execution continues from the point immediately following the receive command. The program can then process the received data and perform further actions based on the input. The Xctl receive command is commonly used for interactive processing within Kicks programs. It allows programs to prompt the user for input, wait for the input to be provided, and then proceed with processing based on the received data. The received data can be used for various purposes, such as validating user input, performing calculations, making decisions, or interacting with external systems. Here I have given an example. Please have a look. Moving to question number 29. What does Xctl read command do? The Xctl read command in Kicks is used to read records from a file within a Kicks program. It allows the program to access and retrieve data from a specific file. When you issue the Xctl read command, Kicks performs the following actions. It specifies the file. The read command specifies the file from which you want to read records. The file can be a VSAM file, QSAM file, or any other supported file type in Kicks. Then it positions the file. If required, you can use the read command with positioning options to position the file at a specific record or key before reading. This allows you to retrieve records from a desired point in the file. Then it reads the record. The read command retrieves the next available record from the specified file. The record is typically stored in a designated storage area defined by your program, such as a working storage area or a specific data structure. Then it processes the record. After reading the record, your program can process the data as needed. This may involve performing calculations, making decisions, updating other files, or generating output based on the read data. Then it repeats the process. If you need to read multiple records from the file, you can repeat the read command within a loop or based on a specific condition. This allows you to read and process subsequent records until you have retrieved all the desired data. The Xctl read command is a fundamental file control command in CICS, providing the capability to read records from files. It allows programs to access data from various file types such as sequential files, indexed files, or database files. The read command can be used for tasks such as retrieving customer information, processing transaction data, or performing database queries. So here I have given an example. Please go through it. Moving to question number 30. What does Xctl write command do? The answer is the Xctl write command in CICS is used to write a record to a file within a CICS program. It allows the program to store or update data in a specific file. When you use the Xctl write command, CICS performs the following actions. It specifies the file. The write command specifies the file to which you want to write the record. The file can be a VSAM file, QSAM file, or any other supported file type in CICS. Then it prepares the record. Before issuing the write command, your program prepares the record data that needs to be written. This involves populating the record with the required information or updating an existing record. Then it writes the record. The write command stores the record in the specified file. It either adds a new record to the file or updates an existing record, depending on the file type and organization. Then it handles file updates. If the file being written is a VSAM file or any file that supports file updates, CICS ensures data integrity by managing the updates to the file. This includes handling locking mechanisms, transaction integrity, and ensuring concurrent access to the file. The Xctl write command is commonly used for tasks such as updating customer records, storing transaction data, or making changes to a database. It allows programs to modify or add data to a specific file within the CICS environment. Here I have furnished an example. Please have a look. Moving to question number 31. What does Xctl start do? The answer is the Xctl start command in CICS is used to initiate the processing of a transaction or program in CICS. It allows a program to invoke another program or transaction and transfer control to it. When you issue the Xctl start command, CICS performs the following actions. It specifies the target program or transaction. The start command identifies the program or transaction that you want to start. It can specify the program name or transaction identifier. Then it provides input data. If the target program or transaction requires input data, you can provide it in the start command. This data can be passed using a COM area or communication area or specific parameters defined by the target program. Next is it transfers control to the target. The start command transfers control from the current program to the target program or transaction. The target program or transaction begins execution and control no longer remains in the calling program. Next, it handles program communication. If necessary, CICS manages the communication between the calling program and the target program or transaction. This can involve passing data between programs, synchronizing program execution, or sharing resources. The Xctl start command is commonly used to initiate the execution of other programs or transactions within the CICS environment. It enables the composition of complex processing logic by invoking multiple programs in a coordinated manner. So here I have given an example. Please go through it. So moving on to question number 32. What does Xctl end multi command do? The answer is this command is used to end a loop that was started with the Xctl do command. Moving on to question number 33. What does Xctl ask time command do? The answer is the Xctl ask time command in CICS is used to retrieve the current system time from the CICS region. It allows a program to obtain the current date and time information for various purposes such as logging, time-based processing, or generating timestamps. When you issue the Xctl ask time command, CICS performs the following actions. It retrieves the current time. The ask time command retrieves the current system time from the CICS region. It obtains the time information from the system clock. Then it stores the time value. The retrieved time value is typically stored in a designated storage area defined by your program. This storage area can be a working storage field or a specific data structure used for time related calculations or comparisons. Then it provides the time to the program. The ask time command returns the current time value to your program. You can access and manipulate this value as needed for your program logic. The time value returned by the ask time command is typically represented in a specific format such as a packed decimal or binary field, depending on the programming language and data representation conventions used in your program. The Xctl ask time command is commonly used to obtain the current system time for various time related operations within a CICS program. This may include generating timestamps for transaction processing, capturing the time of specific events, calculating time durations, or implementing time-based validations. So here I have given an example. Please have a look. Okay, moving to question number 34. What does Xctl assign command do? The answer is the Xctl assign command in CICS is used to assign or modify values in various control areas or control blocks within a CICS program. It allows you to manipulate and control the behavior of the CICS environment. When you issue the Xctl assign command, you can perform the following actions. It modifies values in control blocks. The assign command allows you to modify values in control blocks such as terminal control table, that is TCT, program control table, that is PCT, file control table, that is FCT, or other Kicks control blocks. This enables you to customize the behavior of Kicks resources or specify specific settings. Set flags or indicators. You can use the assign command to set flags or indicators that affect the subsequent processing within Kicks. These flags can control the flow of execution or influence certain behaviors. Manipulate system control information. The assign command can modify system control information, such as changing the values of system parameters or modifying the characteristics of specific Kicks resources. Next is retrieve information. In addition to modifying values, the assign command can also be used to retrieve information from control blocks or system control areas. This allows your program to access specific settings or data within the Kicks environment. The specific usage and available options of the assign command depend on the specific control area or control block being modified. The command parameters specify the target control area and the values to assign or retrieve. The exact Kicks assign command provides flexibility and control to your Kicks programs, allowing them to customize the behavior of the Kicks environment to suit specific requirements. It is a powerful command for manipulating and managing Kicks resources and settings programmatically. Here I have given a few examples, so please go through it. Moving to question number 35. What does exact Kicks set command do? The answer is the exact Kicks set command in Kicks is used to modify or update various attributes or settings within a Kicks program. It allows you to control the behavior of the program and the interaction with the Kicks environment. When you issue the exact Kicks set command, you can perform the following actions. Set program attributes. The set command allows you to modify program attributes such as program name, transaction ID, task priority, execution mode, or other program specific settings. These attributes determine how the program interacts with Kicks and other programs or transactions. Control program flow. You can use the set command to control the flow of program execution. This can involve setting indicators or flags to influence program logic, conditionally branching to different sections of code, or specifying actions to be taken based on certain conditions. Modify communication options. The set command can be used to modify communication options, such as changing the terminal type or communication mode. This allows your program to adapt to different terminal environments or communication requirements. Next is customize resource access. You can use the set command to customize the access or behavior of Kicks resources. This can include specifying file handling options, record locking modes, database isolation levels, or other resource specific settings. The exact Kicks set command provides flexibility and control to your Kicks programs, allowing them to adapt and customize their behavior based on specific requirements. It enables you to dynamically modify program attributes, control program flow, and interact with various Kicks resources and settings. Here I have given a few examples, so please have a look. Moving to question number 36. What does exact Kicks inquire command do? The answer is the exact Kicks inquire command in Kicks is used to retrieve information about various resources or control blocks within the Kicks environment. It allows a program to inquire about the status, characteristics, or attributes of specific resources. When you issue the exact Kicks inquire command, you can perform the following actions as mentioned. Retrieve resource information. The inquire command allows you to retrieve information about Kicks resources such as files, terminals, transactions, programs, queues, or other system control areas. You can inquire about the status, availability, or characteristics of these resources. Next is obtain status or statistics. The inquire command can provide status information or statistical data related to Kicks resources. For example, you can inquire about the number of records in a file, the utilization of a storage area, the availability of a transaction, or the status of a terminal. Next is check for resource existence. You can use the inquire command to check the existence of a particular resource. This can help determine whether a resource is available before attempting to access or manipulate it. Next is capture attribute values. The inquire command allows you to capture attribute values of Kicks resources or control blocks. This can include information such as file attributes, terminal attributes, transaction attributes, or program attributes. The exact Kicks inquire command provides a means for Kicks programs to gather information dynamically about the Kicks environment and its resources. It enables programs to make decisions, perform validations, or take specific actions based on the retrieved information. Here I have given a few examples. Please go through it. Okay, so moving on to question number 37. What does exact Kicks Getmain do? The answer is the exact Kicks Getmain command in Kicks is used to dynamically allocate storage or memory within a Kicks program. It allows the program to request a block of storage from the Kicks region for its own use. When you issue the exact Kicks Getmain command, Kicks performs the following actions as mentioned. Specifies the requested storage size. The getMain command specifies the size of the storage block that the program requires. The size is typically specified in bytes and represents the amount of memory that the program wants to allocate. Next is allocates the storage. Kicks allocates the requested storage block from the available storage pool within the Kicks region. The storage block is then made available to the program for its use. Next is it provides a storage address. After the storage block is allocated, the getMain command returns the starting address of the allocated storage block to the program. This address is typically stored in a working storage field or a pointer variable, which the program can use to access and manipulate the allocated memory. Next is it manages storage release. It is the responsibility of the program to release the allocated storage once it is no longer required. The program can use the exact Kicks Freemain command to release the memory and make it available for reuse. The exact Kicks getMain command is commonly used when a program needs to dynamically allocate memory during its execution. This can be useful for managing variable sized data structures, creating temporary work areas, or dynamically managing data buffers. Here I have given an example. Please go through it. Moving on to question number 38. What does Xctl Freemain do? The answer is the Xctl Freemain command in Kicks is used to release or deallocate storage that was previously allocated using the Getmain command. It allows a program to return the allocated memory back to the Kicks region for reuse. When you issue the Xctl Freemain command, Kicks performs the actions as mentioned here. It specifies the storage address and size. The Freemain command specifies the starting address and size of the storage block that the program wants to deallocate. The address and size should match the previously allocated storage block that needs to be released. Then it releases the storage. Kicks releases the specified storage block, making it available for reuse by other programs or transactions within the Kicks region. The storage block is no longer accessible or usable by the program that issued the Freemain command. By releasing the storage using Freemain, programs can efficiently manage memory resources and avoid memory leaks. It ensures that allocated memory is returned to the system pool and can be reused by other programs or transactions when needed. So here I have given an example. Please have a look. Moving to question number 39. What does Xctl Xctl tran do? The answer is this command is used to transfer control from one task to another within the same Kicks region. Moving to question number 40. What does Xctl link PGM do? The answer is the Xctl link PGM command in Kicks is used to invoke or link another program within a Kicks program. It allows one program to call and transfer control to another program known as the target program. When you issue the Xctl link PGM command, Kicks performs the actions as mentioned here. It specifies the target program. The link PGM command identifies the program that you want to invoke. It typically specifies the program name or a symbolic name associated with the target program. Then it transfers control to the target program. The link PGM command transfers control from the current program to the target program. The target program begins execution and control is temporarily handed over to it. Passes parameters or data. If the target program requires input data or parameters, you can pass them using the COM area, that is communication area, or specific linkage options defined by the target program. This allows the target program to access and process the passed data. Next, it handles program communication. Kicks manages the communication and interaction between the calling program and the target program. This can involve passing control and data between programs, synchronizing program execution, and sharing resources. Once the target program completes its execution or reaches an appropriate exit point, control is returned back to the calling program, allowing it to resume execution from the point following the link pgm command. The Xctl link pgm command is commonly used when you want to invoke a specific program from within another program while maintaining the context and returning control to the calling program. Here I have given an example. Please go through it. Okay, moving to question number 41. What does Xctl return trans command do? The answer is, this command is used to terminate a transaction and return control to the terminal or application that initiated it. Moving to question number 42. What does Xctl send map command do? The answer is, the Xctl send map command in Kicks is used to send a formatted screen map to a terminal for display. It allows a Kicks program to present information to the end user by sending a map to the terminal. When you issue the Xctl send map command, the actions take place which I have mentioned here. Specifies the map name. The send map command identifies the screen map that you want to send to the terminal. The map name is typically a symbolic name associated with the map definition. It sends the map to the terminal. The send map command sends the specified map to the terminal for display. The terminal will interpret and render the map according to its defined characteristics, such as fields, labels, colors, or any other formatting specified in the map definition. Transfers control to the terminal. After sending the map, the send map command transfers control from the program to the terminal, allowing the end user to interact with the displayed map. The user can enter or modify data in the fields presented on the screen. Handles user input. Once the user interacts with the displayed map, the terminal captures the user's input and may validate or process the entered data according to the logic defined in the program. The send map command is often used in conjunction with the receive map command, which allows the program to receive and process user input from the terminal after the map has been displayed. This enables interactive data entry and screen-based interaction between the user and the Kicks program. So here I have given an example. You may have a look at it. Okay. Moving to question number 43. What is EIB? Explain in details. The answer is, in Kicks, EIB stands for Execute Interface Block. The Execute Interface Block is a control block that provides important information and control flags to a Kicks program during its execution. It contains various fields that convey details about the current execution, environment, transaction, and other relevant information. The EIB is accessible to Kicks programs and can be referenced using the EIB symbol or a related symbolic name. Some of the key fields in the EIB include: number 1, EIB TRM ID. This field contains the terminal ID or identifier associated with the current transaction. It identifies the user's terminal from which the transaction is initiated. Number 2, EIB AID. The attention identifier field indicates the AID, that is attention identifier key pressed by the user on the terminal during transaction processing. It allows programs to determine if specific attention keys like enter, clear, or PF keys were pressed. Number 3. EIB Kicks. This field contains the Kicks release level, indicating the version of Kicks under which the program is executing. It helps programs identify the capabilities and features available in the Kicks environment. Number 4. EIB Calend. The call level field indicates the current call level of the program. It provides information about the nesting level of the current program call within the transaction. Next is EIB TR code. The transaction code field contains the transaction identifier associated with the current transaction. It represents the unique name or identifier assigned to the transaction being executed. Next is EIB RESP. The response code field is used to return a response or status code to Kicks after the program execution. It indicates the success or failure of the program's processing and provides feedback to Kicks about the outcome. These are just a few examples of the fields available in the EIB. The EIB provides a range of information and control options that Kicks programs can utilize to customize their behavior, interact with the Kicks environment, and process transactions effectively. Moving to question number 44. How dynamic memory allocation is handled in the Kicks program? The answer is, in Kicks, dynamic memory allocation is handled using the Xctl Getmain and Xctl Freemain commands. These commands allow a Kicks program to dynamically allocate and deallocate memory during its execution. When issuing the Getmain command, the program specifies the size of the memory block it requires in bytes. Kicks then allocates the requested memory block from the available storage pool within the Kicks region and returns the starting address of the allocated memory block to the program. The program can then use this address to access and manipulate the allocated memory. Here I have given an example of Getmain. Please have a look. Now, when issuing the Freemain command, the program specifies the starting address and size of the memory block that needs to be released. Kicks then deallocates the specified memory block, making it available for reuse by other programs or transactions within the Kicks region. So for Freemain also, I have given an example here. Please go through it. Moving to question number 45. What is trans ID in Kicks? In Kicks, trans ID refers to the transaction identifier. A transaction identifier or trans ID is a unique name or identifier assigned to a transaction within the Kicks environment. It serves as a means of identifying and distinguishing different transactions that can be initiated by users or programs. When a transaction is defined in Kicks, it is assigned a trans ID, which can be a combination of alphabetic and or numeric characters. The trans ID is used to invoke or initiate a specific transaction within the Kicks region. The trans ID plays a crucial role in the execution and control of transactions in Kicks. It allows users or programs to initiate a specific transaction by entering the corresponding trans ID at the terminal or by invoking it programmatically. So here I am mentioning some key points regarding trans ID in CICS. First one is unique identification. Each transaction within a CICS region must have a unique trans ID. This ensures that the correct transaction is invoked when requested by users or programs. Next is transaction invocation. Users can initiate a transaction by entering its trans ID at the terminal, typically through a CICS menu or command interface. Programs can also invoke transactions programmatically using the appropriate CICS command. Examples may be exec kicks start trans ID. Next is transaction routing. The trans ID is used by CICS to route the transaction to the appropriate program or program flow associated with that trans ID. CICS uses the trans ID to determine the program linkage or processing logic defined for that particular transaction. Next is transaction management. CICS tracks the execution and state of each transaction using the trans ID. It manages resources, controls transaction flow, and ensures data integrity and consistency within the transaction boundaries. In summary, trans ID is a unique identifier assigned to transaction in CICS. It allows users or programs to initiate specific transactions within the CICS environment and enables CICS to route and manage the execution of those transactions appropriately. Moving to question number 46. Which command is used to read a record from a VSAM file in CICS? The answer is, in CICS, the command used to read a record from a VSAM, that is virtual storage access method file, is exec-kicks read. Here I have given an example for this. Please go through it. Moving to question number 47. What does exec-kicks start br do? The exec-kicks start br command is used in CICS to initiate a browse operation on a VSAM file. It positions the program at a specified location within the file, allowing it to read records sequentially without modifying or updating them. Here I have given an example for this. Please have a look. Moving to question number 48. What is the difference between a task and transaction in CICS? The answer is, in summary, the key differences between tasks and transactions in CICS are as follows. Task. It represents an individual program's execution instance within CICS, operates at the program level, can be concurrent or serialized, and has its own working storage and control blocks. On the other hand, transaction means a logical unit of work or a set of related operations, operates at the application level, involves multiple programs, is identified by a transaction identifier, that is trans ID, and can span multiple tasks. Tasks provide the execution context for individual programs, while transactions provide a higher level organizational structure for coordinating and managing application functionality within CICS. Moving to question number 49. Which CICS command is used to release a temporary storage queue, that is TSQ? In CICS, the command used to release or delete a temporary storage queue is exec-kicks delete queue. The exec-kicks delete queue command allows you to remove a TSQ from the CICS region, freeing up the resources associated with it. Here I have given an example of the delete queue command. Please have a look. Moving to question number 50. Congratulations for the half century. You have learned enough of CICS by now. So the question is, which CICS command is used to start a transaction? The answer is, the CICS command used to start a transaction is execkicks start trans ID. The execkicks start trans ID command allows you to initiate the execution of a specific transaction within the CICS region. It triggers the execution of the program or program flow associated with the specified transaction identifier, that is trans ID. Here I have given an example of the start trans ID command. You may have a look at it. Moving to question number 51. Which CICS command is used to define a new file? The answer is, the execkicks define file command is used to create a new file definition within the CICS region. Here I have given the syntax of it. Please have a look. Moving to question number 52. What is the maximum length of a CICS task name? In CICS, the maximum length of a task name, also known as a transaction identifier, that is trans ID, is 4 characters. Moving to question number 53. Which of the commands is used to display a message in the CICS terminal? The answer is, the execkicks send text command allows you to send a message or text string to the terminal display of the user. It is commonly used to provide informational or error messages to the user during the execution of a CICS program. So here I have given an example for the same. Please go through it carefully. Moving to question number 54. Which CICS facility is used to manage resources such as storage and devices? The answer is, the CICS facility used to manage resources such as storage and device is called the CICS Resource Definition Online, that is RDO facility. The CICS Resource Definition Online, that is RDO facility, is a component of CICS that allows you to define and manage various resources used by CICS applications. It provides a centralized mechanism for defining and configuring resources such as files, programs, transactions, terminals, queues, and more. The key features and capabilities of the CICS RDO facility include: number 1. Resource definition. The RDO facility allows you to define and configure various resources used by CICS applications. This includes defining files such as VSAM, sequential, or DB2, programs such as COBOL, PLI, or assembler, transactions, that is trans IDs, terminals, queues, that is temporary storage queues or TSQs, and other CICS specific objects. Next is resource control. RDO provides a centralized control mechanism for managing and controlling resources. It allows you to specify access permissions, security attributes, and other properties for resources. It ensures that resources are accessed and utilized in a controlled and secure manner. Next is dynamic resource allocation. RDO enables dynamic allocation and deallocation of resources during runtime. This allows applications to request and release resources on demand, improving resource utilization and flexibility. Next comes resource level security. RDO provides security features to control access to resources. It allows you to define security profiles and access control lists, that is ACLs, to restrict or grant access to specific resources based on user or group permissions. Next is system-wide resource management. RDO allows you to define and manage resources at a system-wide level. It provides a centralized view and control of resources across multiple CICS regions or systems, allowing for consistent resource management practices. The CICS RDO facility plays a crucial role in the administration and configuration of resources within the CICS environment. It provides a centralized mechanism for defining, managing, and controlling resources, ensuring efficient resource utilization and supporting the execution of CICS applications. Moving to question number 55. What does Xctl get and Xctl put do? In CICS, the Xctl get and Xctl put commands are used for reading and writing data from and to a file respectively. These commands are primarily used for file processing operations in CICS programs. First, coming to Xctl get. The Xctl get command is used to read a record or a set of records from a file. It allows you to retrieve data from a specific record or a range of records based on criteria such as a key value or a search condition. Here I am furnishing an example of the get command. Please have a look. Now coming to Xctl put. The Xctl put command is used to write a record or a set of records to a file. It allows you to create or update data in a specific record within the file. For this also I have given an example here, so you may have a look at it. The put command writes the records from the specified data area to the file. If the record already exists, it is updated with the new data. Moving to question number 56. Which CICS command is used to delete a record from a file? In CICS, the command used to delete a record from a file is exectl delete. The exectl delete command allows you to remove a specific record from a file. It is used when you want to delete a record based on certain criteria such as a key value or a search condition. Here I have given an example of the delete command syntax. It's worth noting that the delete command operates at the record level and removes the specific record identified by the key value or other criteria. It does not delete the entire file or any other records in the file. Moving to question number 57. Explain the use of DCT. DCTs stand for Destination Control Tables that are aesthetically used in CICS to define TDQs. Moving to question number 58. Name at least one of the ways by which a transaction can be terminated. The answer is use the command exectl sync point and assume it as LUW, last unit of work. Moving to question number 59. Can a CICS code be a part of a copybook? If so, then what are the outcomes after compilation? The answer is a CICS code can easily be a part of a copybook, but reprocessing has to be done after compilation process. Moving to question number 60. What is meant by an AICA, that is ICA event? The answer is AICA or ICA event is just a runaway task that is executed at a later stage. Moving to question number 61. Can ESDS files be accessed from CICS? The answer is yes. Moving to question number 62. What is the procedure to solve an ASRA event? ASRA event. The answer is all you have to do is to start with the CEBR and then call for instructions of offsets. Moving to question number 63. How errors are handled in CICS programs? The answer is in order to handle the errors, you will need to check the EIB RESP after calling the program. An alternative option would be to put the handle condition to use. Moving to question number 64. Highlight the difference between a symbolic map and physical map. The answer is symbolic map happens to be a data structure, whereas a physical map is basically a load module. Moving to question number 65. What is the difference between send map data only and send map map only? The answer is send map data only. Through this, the data is sent without the layout. It is used in order to refresh the data that comes to the screen. Next is send map map only. Through this, only the map is sent and not the data. Whenever we are in the process of sending menu screens, the data is never sent. Moving to question number 66. What is MDT? Furthermore, comment on FRSet and FSet. The answer is MDT stands for Modified Data Tag. If the modification of the field has to be done on the screen, then MDT acts as a bit of an attribute byte. MDT comes into play during an input operation. FRSet is used to reset MDT. The field will be sent till the time the MDT has been set again by FRSet. FSet is in charge of ensuring that field is transmitted by MDT. FSet comes into play during an output operation. Moving to question number 67. Explain how dissect parameter is used in BMS. The answer is dissect parameter is used in BMS in order to give shape to a symbolic map. Moving to question number 68. Can QSAM files be accessed from CICS? The answer is no. Moving to question number 69. What does a CICS translator do? The answer is there is a linkage area associated with every program. In this area, the EIB block is generated by the CICS translator. Moving to question number 70. What is the effect of including the trans ID in the exec_kicks return command? The answer is including the trans ID parameter in the exec_kicks return command allows you to specify the transaction identifier to which control should be returned after completing the current transaction. When you issue the exec_kicks return command with the trans ID parameter, it instructs CICS to transfer control back to the specified transaction. This means after the current transaction completes, CICS will initiate the specified transaction for execution. Here I am giving an example of how the exec_kicks return command with trans ID is used. Please have a look. What is the difference between getting the system time with EIB time and ask time command? The answer is the EIB time field provides the start time of the current transaction, while the ask time command allows you to obtain the current system time dynamically during the execution of the program or transaction. The EIB time field is useful for tracking the duration of the transaction, while the ask time command is used to retrieve the absolute system time for various purposes. Moving to question number 72. What is meant by program re-entrance? Program re-entrancy in the context of IBM's CICS environment refers to the ability of a program to be executed concurrently by multiple transactions without causing conflicts or inconsistencies. When a program is re-entrant, it means that multiple instances of the program can be active and executing simultaneously without interfering with each other's data or execution flow. Each instance of the program maintains its own independent copy of working storage and does not share resources or variables with other instances. Moving to question number 73. What is BMS? BMS stands for Basic Mapping Support, and it is a component of IBM's CICS environment. BMS provides a set of facilities and tools for designing and implementing formatted screens or maps for use in CICS applications. In the context of CICS, a map refers to a predefined screen or display layout that defines the structure and formatting of data displayed to the user. BMS provides a programming interface and utilities that allow developers to create and manipulate these maps, enabling the design of interactive user interfaces for CICS applications. The key components of BMS include: number 1, DFHMSD, that is map set definition. This is a CICS resource that defines the attributes and characteristics of a set of related maps. The map set definition specifies the fields, attributes, and formatting rules for individual maps within the map set. Next is DFHMDI, that is map definition. This defines the structure and layout of an individual map within a map set. It includes field definitions, attribute settings, and positioning information for each element on the map. Third one is DFHMDF, that is map copybook. This is a COBOL copybook or equivalent definition that maps the map's fields to data structures in the programming language being used. It provides a way to access and manipulate the data on the map within the application program. Next is DFHM DFR, that is map set and map control blocks. These control blocks are generated by CICS during map set and map initialization. They contain information about the map set and map definitions and are used by the application program to interact with the maps. BMS allows developers to design and create maps using a design tool such as the BMS or CEMT transaction or an external map design tool. Once created, these maps can be displayed, updated, and interacted with using CICS application programs. Overall, BMS provides a framework for designing and implementing user-friendly screens or maps in CICS applications, facilitating efficient data input and presentation for end users. Moving to question number 74. What are the attribute values of skipper and stopper fields? The answer is, in the context of IBM's basic mapping support, that is BMS, in CICS, the skipper and stopper attributes are used to control the movement of the cursor or input focus on a formatted screen or map. Here I have given an example. Please have a look. The skipper attribute is used to indicate that a particular field should be skipped during cursor movement. When the cursor encounters a field with the skipper attribute, it automatically moves to the next field in the logical order without allowing any user input. Skipper fields are often used to create navigation or control logic within a map. The skipper attribute is represented by the value skip in the ATTRB parameter of the DFH MDI, that is map definition macro, or the BMS map design tool. Now coming to stopper attribute. ATTRB equals stop within brackets. The stopper attribute is used to halt cursor movement and prevent further tabbing or cursor advancement. When the cursor encounters a field with the stopper attribute, it remains on that field and the user cannot move the cursor beyond it. Stopper fields are commonly used to enforce mandatory data entry or to indicate the end of a section on a map. The stopper attribute is represented by the value stop in the ATTRB parameter of the DFH MDI, that is map definition macro, or the BMS map design tool. By using skipper and stopper attributes appropriately, developers can control the user's navigation and input behavior on formatted screens or maps in CICS applications, ensuring a smooth and intuitive user experience. Moving to question number 75. How do you set the MDT option to on status even if data is not entered? The answer is, if you want to set the MDT option to on status even if data is not entered, you can use the BMS macros or the BMS map design tool to manually toggle the MDT flag. Here is an example. Number 1, using BMS macros. In the DFH MDI, that is map definition macro, or the BMS map design tool, specify the MDT option as shown here. The ATTRB parameter with MDT enables the MDT flag for the field. The ask IP attribute makes the field skipper, allowing the cursor to bypass it during normal cursor movement. Number 2, using BMS map design tool. If you are using a BMS map design tool, refer to the specific tool's documentation or interface to set the MDT option to on status. The exact steps may vary depending on the tool you are using. By setting the MDT flag manually, the field will be treated as modified even if no data is entered. This can be useful in scenarios where you need to indicate that a field has been visited or touched by the user, regardless of whether they have entered any data or not. Please note that the specific syntax and options may vary depending on the version of CICS and the BMS map design tool you are using. It's important to consult the documentation for your specific CICS version and the map design tool for accurate usage details. Moving to question number 76. Which CICS service transaction is used to gain accessibility to CICS control tables? The answer is the CICS service transaction used to gain accessibility to CICS control tables is called CIDA, CICS Execute Definition 8. CIDA provides an interactive interface for performing various administration tasks related to CICS control tables. When you initiate the CIDA transaction, you can access and modify CICS control tables such as file definitions, that is FCTs, transaction definitions, that is TCTs, program definitions, that is PPTs, and more. This allows you to define, update, or delete entries in these control tables as needed. Moving to question number 77. What is CEMT transaction? The CEMT, that is CICS Execution Management Transaction, is a system-defined transaction in IBM's CICS environment. It provides a command-driven interface for managing and monitoring CICS resources and system components. The CEMT transaction allows authorized users to perform various administrative tasks and obtain information about the CICS region. It provides a set of commands that can be issued interactively to query and manipulate CICS resources and monitor system activity. Some common tasks that can be performed using the CEMT transaction include: number 1, displaying system status. You can use CEMT to view information about the current state of CICS resources, such as the active transactions, program definitions, file status, and more. Next, starting and stopping transactions. CEMT allows you to initiate or terminate individual transactions within the CICS region. You can start, stop, or force the termination of transactions as needed. Next is managing program definitions. CEMT enables you to define or modify program definitions in CICS, specifying attributes like the program name, load library, entry point, and more. Working with files and queues. You can use CEMT to manipulate file definitions, queue definitions, and associate resources, such as opening or closing files, manipulating queues, and checking file status. Next is controlling system resources. CEMT provides commands to manage system resources like regions, tasks, storage, and system components. You can inquire about or control various aspects of the CICS environment. Here I have given a few examples. Please have a look. Moving to question number 78. What is CEBR transaction? Temporary Storage Browse, that is CEBR, is a debugging aid that you can use to browse, that is read without changing, and manipulate the contents of CICS temporary storage queues. You can also use it to transfer a transient data queue to or from a temporary storage queue. Here I have given a few examples of CEBR. Please have a look. Here, 3 separate transactions are triggered one by one. First one is CEBR TSQ1. Second one is CEBR /Q TSQ1 /. Third one is CEBR Q, then a hexadecimal value. Moving to question number 79. What is CIDA transaction? The answer is the CIDA transaction is a system-defined transaction in IBM's CICS environment. It provides an interactive interface for performing administration tasks related to CICS resource definitions. The CIDA transaction allows authorized users to define, modify, or delete various CICS resources and control tables. These resources include files, transactions, programs, queues, terminals, and more. It serves as a convenient tool for managing the configuration and administration of CICS resources. Through the CIDA transaction, you can perform tasks such as number 1. Defining and modifying file definitions, that is FCTs. CIDA enables you to create or update file definitions, specifying attributes such as file name, access method, record format, and more. Next is defining and modifying transaction definitions, that is TCTs. You can define or modify transaction definitions, specifying attributes such as transaction ID, program name, security requirements, and more. Next is defining and modifying program definitions, that is PPTs. CIDA allows you to define or modify program definitions, specifying attributes such as program name, load library, entry point, and more. Next is managing resource definitions. CIDA provides the ability to define or modify other CICS resources like queues, terminals, devices, and more. Next is displaying resource information. CIDA allows you to display information about various CICS resources, including their current definitions, attributes, and relationships. Here I have given an example for CIDA transactions. Please go through it. Moving to question number 80. How do you dynamically set the cursor position to a specific field? In IBM's CICS environment, you can dynamically set the cursor position to a specific field on a formatted screen or map by using the cursor command. The cursor command allows you to control the position of the cursor during program execution. To dynamically set the cursor position to a specific field, you need to know the field's map symbol or field attribute in advance. Here I have given an example to show how you can use the cursor command. Please go through it. In this example, the cursor command is used in conjunction with the send map command. It specifies the field name parameter, which represents the map symbol or field attribute of the desired field. The cursor will be positioned on that field when the map is displayed. It's important to note that the field you are setting the cursor to should be defined as an input field and allow cursor movement. Additionally, the specified field name must correspond to a valid field on the map being sent. Moving to question number 81. What is the difference between start and Xctl? The answer is start is a command used to start a new task. It is an interval control command. On the other hand, Xctl is a command used to pass control to a program within the same task. It is a program control command. Okay, moving to question number 82. What are the types of processes that are used to create a map in CICS? The answer is following are the three types of processes that are used to create a map in CICS: DFH-MDF, DFH-MDI, and DFH-MSD. I have already discussed about this before. Moving to question number 83. What is the default size of COM area in CICS? The answer is the default size of COM area in CICS is 65K. Moving to question number 84. What do you understand by the term pseudo-conversational programs? The answer is the pseudo-conversational programs respond to user actions or events. It is a subtype of the conversational program which only runs when it is started or called by another program. It also needs certain actions of the users like hit enter, etc. It is also called an event-based program. Moving to question number 85 and the last question. how can you classify a CICS program? The answer is, we can classify a CICS program into the following types. Number 1, conversational programs. Number 2, non-conversational. And number 3, pseudo-conversational programs.
Please like and share the video if you love this update, and subscribe my channel if you have not done already. Also, do not forget to let me know your feedback in the comment box. Thanks a lot for watching, and till we meet again, bye bye from your host Tapajyoti.